In part A, since we know that x1, x2, x3 all the way to xn are in a geometric progression, we can write xr equals to x1 multiplied by a capital R to the power of small r minus 1, where capital R is our common ratio. Next, since we are given that yr is equal to log of xr plus 2000, we can write yr equals to log of x1 times capital R to the power of small r minus 1 plus 2000, which we can then simplify by bringing the power down to become log of x1 plus r minus 1 times log of capital R plus 2000. Thereafter, to show that y1, y2, y3 all the way to yn are in an arithmetic progression, we simply have to show that the difference between yr and yr minus 1 is equals to a constant. Since we have found yr earlier, we can substitute the r in yr as r minus 1 to obtain yr minus 1. And yr minus 1 will be equals to log of x1 plus r minus 2 times log of capital R plus 2000. Now that we have obtained yr and yr minus 1, we can then proceed to find out the difference between them, and the difference between them is shown to be equals to log of capital R, and since R is a constant, log of capital R will be a constant as well, and therefore y1, y2 all the way until yn must be in an AP. In part B, we are given that y1 is equals to 1998, and therefore we can make use of this value to find out what is the corresponding x1 value by substituting 1998 into our yr equals to log of xr plus 2000 equation. And eventually, we will arrive that x1 is equals to 10 to the power of minus 2. Also, we are given that the common difference d is equals to 1. And based on what we have shown earlier, we know that the common difference in the arithmetic progression is equals to log capital R, which means log of capital R must be equals to 1, and therefore capital R, or our common ratio, is equals to 10. With the first term x1 and the common ratio R found, we can then write down the general term of the geometric series for xr, and xr will be equals to x1 times capital R to the power of small r minus 1, which is equals to 10 to the power of minus 2 times 10 to the power of r minus 1, which we can simplify to become 10 to the power of r minus 3, which is what the question wants us to show. In part C, we are asked to find out z1 plus z2 plus z3 all the way until zn, where zr is equals to xr plus yr. And we can rewrite this as x1 plus x2 plus x3 all the way to xn plus y1 plus y2 all the way to yn. The reason for doing so is because we know that x follows a geometric series and y follows an arithmetic series, and we can then apply appropriately the summation formula for an AP and a GP. And this gives us the following forms, and we can simplify and eventually arrive at the sum of z1, z2 all the way to zn to be equals to 10 to the power of n minus 1 divided by 900 plus n over 2 times 3995 plus n.